Hello, my little mathematicians. Today, we're going to go through the different properties that we need to know. Okay. So, the first one is the identity property. So, think of it as a number wants to keep a sense of self, its own identity. So, what can you add to a number and still be able to not change its value? Yeah, a zero. And what can you multiply a number by and not change its value? You multiply anything by 1. Okay, so right here, we're going to give you both the algebraic example and then a numerical example. So this is saying anything plus 0 will remain its whatever it started with. So like if you started with 20, if you add 0 to it, it'll still end as 20. Okay, and then anything that you start with, if you multiply it by 1, it'll keep a sense of self. It'll remain with its own identity. It won't change its value. Just like, if it was 7, if you multiply it by 1, it still stays a 7. Okay, so here's the algebraic example saying it'll work for any number, and then here's me actually plugging it in with some example. Okay, so that's the identity property. It means what can you add or subtract to something, and whatever it started as, it still ends the same. It kept a sense of self or identity. Most of these we might use, but they don't really get used until geometry, to be honest. So for our sake, a lot of times it'll probably be a multiple choice, and you'll have to identify like, hey, which property just happened here? Well, it started as a 7 and it ended as a 7, so it's the identity property. And was it the identity of multiplication or addition? Multiplication. This one was the identity of addition. Okay. Then we have another one called the commutative property. Okay, what's the commutative property? It's saying that you can move numbers around and you still get the same answer when you add or multiply. So we're saying that like 2 plus 5 is 7, and 5 plus 2, if I switched them or moved them, I still get 7. So addition and multiplication, like 2 times 3 is 6. If I switched them, 3 times 2 is still 6, right? So according to the commutative property, you can move numbers around and it doesn't change the value. Okay, now only addition or multiplication, because if you were to subtract, 3 minus 2 is very different than 2 minus 3. One is a positive one, the other one ends in a negative one. Okay, so subtraction, you can't do the commutative property. Same thing with division, order matters. 2 over 1 is 2, but 1 over 2 is a half. So order matters. But for addition and multiplication, it doesn't. So we said we can do the commutative property, meaning A plus B is the same as B plus A. Okay, I could switch them around. Same thing if I'm multiplying. A times B is the same as B times A. Let's actually plug numbers in. 8 times 4, I could switch them and move them to be 4 times 8. Why? Because 8 times 4 is 32 and 4 times 8 is 32. This is an example of the commutative property of multiplication. This is an example of the commutative property of addition, because 11 plus 6 I can move and flip to be 6 plus 11. Why does that work? Well, because 11 plus 6 is 17 and 6 plus 11 is also 17. So according to the commutative property, I can move numbers around when dealing with addition or subtraction, and it won't matter. I'll still get the same answer. Okay, now that's different than the associative property. Okay, the associative property, notice how here the order changes. It was AB, now it's BA, the numbers moved. But for the associative property, ABC, it's still ABC. The order didn't change. But the groupings changed right here. Think of parentheses as groups of who hangs out with who. So here, B was hanging out with A, and then I guess maybe B's mom was like, I don't want you associating with A anymore. They're a bad influence on you. I want you to start hanging out with C. And so B was like, sorry, A, we can't be friends anymore. I'm going to hang out with C now. So I know, lame analogy, but hopefully it'll help you remember your groupings changed. And groups are like who you associate with. So B was associating with A, and now all of a sudden A is left in the dust, and B is associating with C over here. So associative property means groupings change, versus commutative property means that the numbers move around because a commuter train, they move, right? If when your commute to work means, or your commute to school, you're driving to and from, you're moving. So numbers moved order. It went AB, now it's BA. So if number or order changes, it's commutative property. If your who is associating with who changes, then it's the associative property. This is the associative of addition. This is the associative of multiplication. So there's plus signs between everything. There's multiplication signs between everything. Okay. And then here shows that no matter what, like even though the groupings changed, because everything was dealing with just addition, it ended as the same answer. Same thing with multiplication. Because there was only multiplication happening, I could switch up the groupings and I'd still end with the same answer. Okay. Notice how we still have, like for identity, you started with 20, it ends with 20. Or you started with 7 and it ends with 7. It didn't lose its sense of self. These two, you have the same numbers on both sides. They either just moved and changed order, or who was hanging out with who changed. Okay, but it's still the same numbers. Distributive property, also it looks a little bit different. Like this side looks nothing like this side. Like where did that extra 3 come from and what? You're distributing the 3 to the 4. And then you're distributing the 3 to the 1. And whatever signs between those in here in the parentheses go between those two right there. So you have 3 times 4 plus 3 times 1. This is me doing it the distributive property way. It simplifies down to 15. This is me doing it the PEMDAS way. I simplified inside parentheses and I got this. So some people are like, why would I ever distribute? Like GEMDAS is so much easier. Whether it's addition or if it's subtraction, who cares? Like GEMDAS is so much easier. Why would I ever distribute? We need to know how to distribute, because what if that was a variable right here? If it was 3 times x plus 1 or 3 times x minus 1. Here, yeah, I can do 4 minus 1, but you can't do x minus 1. So then I would have to distribute the 3 to the x and then distribute the 3 to the negative 1. So distributive property comes into play when these are variables and we can't, we don't know what to substitute in for them. Then we do distributive property. So that will come up later, but we just want to know what the different properties are. Okay, go back and study these. Remember, whatever, if it starts the same and ends the same, it didn't lose its sense of self. Its identity stayed the same. It's the same on both sides. The order just changed. The numbers moved or commuted from one place to another. The left and right was still kind of the same. It's just the associative groupings changed, like who's associating with who. So 3 was hanging out with 6, and then all of a sudden 6 started hanging out with 4. 6 was associating with different people. And then you have the distributive property, which is the 3 was out in front, and now it's being distributed to the 4 and the 1. Okay, so it would either show this to this, or it would show this to this. This is it simplified. It distributed the 3 to the 4, which is 12, and then it distributed the 3 to the 1, which is 3. So if you're deciding multiple choice, it would either be this with this or this with this. Either line is still an example of the distributive property happening. 3 times 4 is 12, plus 3 times 1 is 3. Okay? And those are the different properties that we're going to be covering.